today we're going to finish determining a limit graphically. So, to recap, we know that the limit as x approaches a of f of x equals some arbitrary value, L, if and only if your right limit equals your left limit, which is equal to the same number. Okay, so things we need to remind ourselves: that answers to limits are y values, that as x approaches infinity, we're talking about the right tail. As it approaches negative infinity, we're talking about the left tail. If the L value is positive infinity, then the function's going up, like we saw in example number 3. If the L value is approaching negative infinity, the function's going down. If the limit goes to two different values, as x approaches a, the limit does not exist. If the limit goes to positive and negative infinity, then it does not exist. And if f of x is oscillating, then the limit does not exist. All right, so let's take a look at a few more examples. So, if we look at example number 16, they are a little out of order. We want to check as x approaches 0 from the left and from the right. Both values are approaching the same value, so we know that the limit is equal to 1. For the next example, we're going to look to see, again, as x approaches 1, from the left, from the right, those y values are approaching the same number, which is 4. So our limit is equal to 4, even though f of 1 is equal to 2. The limit is what the function y values are approaching. Okay, if we look at the next example, 24, f of negative 2 is right where our vertical asymptote is, so it does not exist. If we're asked to look at the limit as x approaches negative 2, then we need to come from the left and from the right. Unfortunately, those are looking at different parts of infinity, so they're not approaching one value, so it does not exist. F of 0, when we look at the graph, here's our x value of 0. There's the y value, it's equal to 4. When we look at the limit as x approaches 0 of f of x, we need to go from the left and from the right. Those are not approaching the same y value, so the limit does not exist. F of 2 does not exist because there's a hole there. But if we look at the limit from the left and from the right, they're approaching the same y value, which is equal to 1/2. F of 4 is right here, so it's equal to 2. And the limit as x approaches 4 from the left and from the right are both approaching positive infinity. All right, one more example with a fairly complicated piecewise function. We'll just take it section by section. So for the first part A, we want the limit as x approaches negative 4 from the left. So we would be outside here. However, there's no graph there, so it does not exist. For the next problem, we want the limit as x approaches negative 2 from the left, so that, and our y values are approaching 2. Part C, we want the limit as x approaches negative 1 from the left. Our y values are again approaching 2. For part D, we want the limit as x approaches 3 from the left. And our y values are approaching 1. In the next column, we want the limit as x approaches -1 from the right. And in that case, our y values are approaching 1. For part B, we want the limit as x approaches 3 from the right. And our y values are approaching infinity. Part C, we want the limit as x approaches 1 from the right. And our y values are approaching 3. And finally, for this part D, we want the limit as x approaches -2 from the right. So in this case, we're going in that direction. And we again have a 2. All right, last column, we want the limit as x approaches -4. The problem is that the limit as x approaches -4 from the left doesn't exist. So regardless of what the value is from the right, they're not going to equal the same value. So this does not exist. The limit as x approaches -1, if we look at part C and part A, those are not approaching the same value. So this also does not exist. If we want the limit as x approaches 3, we need to look at the left limit and the right limit. And we have 1 and infinity. So again, our limit does not exist because they're not going to the same value. If we look at the limit as x approaches -3, then we'll need to look at the graph. As x approaches -3 from the left, f of x is approaching 1. As x approaches -3 from the right, f of x is approaching 1. So in this case, our limit does exist, and it's equal to 1. And finally, we need to do the limit as x approaches -2. We looked at x approaching -2 from the left and got 2. We also looked at the limit as x approached -2 from the right and got 2. So since they're equal to the same value, the limit as x approaches -2 of f of x is 2. Let me know if you have any questions. Okay, let's take a look at a few more examples. So for example number 1, we're going to draw a quick sketch of this graph. It's a line, goes through 0, 3, with a slope of 2. Okay, so we want the limit as x approaches -2 from the left of f of x, and that will equal -1 if we were to have graphed it a little more in a little more detail. Next, we want the limit as x approaches 3 from the right, and we will get that f of x is approaching, or the limit is approaching 9. And then the limit as x approaches 1, we can see we need to check from the left and from the right, but in both cases we're approaching the y value of 5. For our second example, we have a parabola. We can factor it. We get that the zeros are at -1 and 6. It's facing down. Okay, so we want the limit as x approaches -4 from the right, which is way off our graph down there. But if we were to plug in -4 and evaluate the function, we would get that the limit is approaching -30. And we can plug the value in and evaluate the y values because there are no holes, because there are no asymptotes, and because there's nothing really crazy going on with our graph. Same thing with part B. The limit as x approaches 7 from the left would be down here. And we get that f of x, the limit as x approaches 7 from the left of f of x is -8. And then if we look at the limit as x approaches 2 from the left and from the right, we get a value of 12. For example number 3, we do need to be more careful about how we graph and evaluate the limits because we know that we have some domain restrictions built into the fact that we're looking at a square root function. This square root function is going to have a 0 when 3x minus 2 equals 0 or when x equals 2/3. So it has a starting point right here, and then it will go through the point 1, 1, and we know since it's a square root function, it kind of hooks off to the right. So now we can start examining some limits. Part A asks for the limit as x approaches -4 from the left. So we're way out here. There is no graph there, so that does not exist. Next, we want the limit as x approaches 5 from the right. So that would be out here. And we'll get that that is equal to the square root of 13. Part C asks us for the limit as x approaches 2/3 from the left. So we're looking again from this direction. And there's no function there. There's no graph. So it does not exist. However, if we come from the right, then we see that our f of x or y values are approaching 0. However, because the limit from the left does not equal the limit from the right, the limit as x approaches 2/3 does not exist. All right, and then for example number 4, we have an absolute value function that we moved right 1 and up 3 and gave a vertical stretch of 2, 2. Okay, so now we want to look at the limit as x approaches -4 from the left, so that's out here. And we'll get that that y value is approaching 13. Part B asks for the limit as x approaches 5 from the right, so in that direction. And we'll get that the y values, the f of x values, are approaching 11. Part C asks for the limit as x approaches 1 from the left. And we can see that our y values are approaching 3. Part D asks for the limit as x approaches 1 from the right. And again, our y values are approaching 3. Since the limit from the left is equal to the limit to the right, which is equal to the same number, our limit as x approaches 1 is equal to 3. For our last example, we have a rational function that factors to x minus 1 times x minus 3 over x minus 1. So it'll reduce to x minus 3, but we'll have a hole at 1, -2. So we can quickly graph the line y equals x minus 3. We want to remind ourselves that we need a hole at 1, -2. And then we'll graph this line. Okay, so we want the limit as x approaches -2 from the left, so that's down here. And we get that the f of x values are approaching -5. If we approach 5 from the right, then we're up here on our graph. and our f of x values are approaching 2. Now we'll look at the limit as x approaches 1 from the left, and our y values are approaching -2. The limit as x approaches 1 from the right, we're still approaching -2 for our y values. So the limit as x approaches 1 of f of x is -2. Let me know if you have any questions.